हेलो बच्चों, हेलो बच्चों, हेलो बच्चों, आवाज़ आ रही है? हाय विमल। चलो, ज्वाइन फास्ट एवरीबॉडी, ज्वाइन फास्ट, ज्वाइन फास्ट। Everybody start with the revision of the previous ones fast. 2 minutes, start the revision, will start in 2 minutes. Functions, 1 on 2, all the conditions, number of 1 on 2 functions, fast. Everybody there? Let's see. iPad. 1 second, student. Screen is visible to everybody? Chalo, everybody. Sound, this all perfect? Where are others? What do you say? Join fast. Kartike, Lucky, Vinayak there. Visible? Okay, good. Perfect. Just 1 minute, we'll start. Let all join, okay. Okay. So today we'll be finishing relation and functions. We'll be doing the PYQs of relation and functions, okay. So join everybody fast. We'll be completing this. Account name is not changing in my laptop. You can change from the mobile and then it will be reflecting it, okay. Yeah, Vinayak, okay, Vinubhai is Vinayak, okay, Vinayak. Where is Karthik? Join fast, everybody. So everybody there? Okay, done. So let's start. I told you I'll be asking the previous stuff. So 5 minutes of asking the old stuff. Now, tell me, Karthike, what is onto function? What is onto function? Come on, write down in the chat, everybody. Let's see how many people remember it. Though I've already shown it in the screen, but still. Everybody has revised whatever was given as a homework. Karthike, good. Range equal to codomain. What about others? Chalo. What about others? Fast. Okay, good, Pavitra ma'am. Good, Vimal. Gokul, what should be the answer? See, for a function to be onto simple, it is range equal to codomain. That's it. Okay, good. Range is equal to codomain, students. Okay. Chalo. Today chemistry class, ma'am will be teaching about, I think so, 1 second. I'll just inform you all. coordination compounds. Okay, so class is at 5, so I'll be taking till 4. 1 5 to 6:30 chemistry class will be there, and 7:30 my class will start. Okay, so right now the class today will be less time, till 4 p.m. only I'll take. Today I'll be taking bigger class, night, have the energy, 7:30 to 11:30 everybody. Okay, 7:30 to 11:30 will be there. Okay, it can be 12 also. 7:30 to 11:30 in the night I'll be taking, so be there everybody. Okay, do inform everybody also. 7:30 to 12 also we can take. Okay, clear? Chalo. So how many number of 1 function we can get? Number of 1 function. Let me give a question to you all. Question is, set A is given as x such that x is a natural number greater than 5 and less than 12. B is a set such that x is a even number greater than 10, less than 26. Find, let's see you can do it. Find the number of 1 function. Today, which chapter? Mostly we'll finish the PYQ of sets, relation and function, and physics, potential and capacitance. Potential and capacitance. Let's see you can do it correct. Yes, no, let's see you can get it correct option. Let's see. Try everybody. Whoever is there, try everybody. From Nishat, Vinayak, Pavitra, Lucky, Kartike, Gokul, try everybody. I have already given the formula. Okay. So try everybody. Very simple formula based question. Okay. If not, I'll again explain, so don't worry. Okay. 15P6. The first answer we got in the chat section from Pavitra ma'am. 15P6. What about others? 15P6. Take your time. I'll be giving the timer. Okay, so don't worry. So 2 minutes timing is there. Okay. Take your time. Get me the correct answer. No need to be in a hurry. I need correct answer. Okay. Okay, we are getting 2 answers as of now. 7P6, 15P6. Okay, what about others? Come on, come on, come on. We need answers from everyone. 30 seconds on the top. Where is Basha, sir? I'm not seeing 7P6 factorial. See, the moment we write factorial, we don't write factorial, Nishad. Okay. 7P6 means, we know NCR means or NPR means. We already know. We don't put the factorial. So, okay. Others. Chalo. Time's up. Okay, let's see. So first, I told you the formula yesterday when I was teaching. What is the formula, students? One-on-one function. What I said, for everybody, those who haven't attended the yesterday class, pay attention, very, very important. This is your set A and this is your set B. How many elements are there in set A? 5. How many elements are there in set B? 6. Function is from where to where? A to B. Okay. So then in that case, the number of 1 function will be directly number of element of set B by number of element of set B permutation number of element of set A. Clear? So this same formula will apply here. Clear? So here x is a natural number greater than 5 means starts from 6, less than 12 means 11. So how many? 6, 7, 8, 9, 10, 11. How many? 3 and 3, 6. So the number of elements in A is 6. Now coming to the next part, it is an even number greater than 10. So what starts from 12, 14, 16, 18, 20, 22. How many? 3, 6. Oh, 24 also. 7. So what do you get? What you have got here? 7 numbers. So number of elements in B is what? 7. So what I told, permutation of elements of B by elements of A. Elements of B was what? 7. Elements of A is what? 6. So 7p6, 7p6. Why a lot of students made mistake? Pavitra, 15p6. Why? Correct. What is the formula I've given? Just a simple shortcut. It won't take more than 10 seconds. Okay. Number of elements in B, permutation number of elements in A. That's it. Nothing more than that. Clear? Everybody got it? Yes, no? Put it in the chat section fast. Gokul got it. Lucky got it. Okay. Keshav, late buddy. I also late. Teacher late, student late. Huh? Deadly combination. Don't make it like that. Okay. Let's see others. Done. Okay. Vinubhai didn't put up the answer. Oh. Come on, Vinayak. Answers, buddy. What about others who were there? Danish didn't put the answer. Pinaki, no answer. Come on, I want answers from everybody, okay? Next time, put answers. Very simple questions, okay? Now, next we'll be reading about composite functions, okay? Next, composite function. Very important, very simple, okay? Now, what is a composite function is? Understand how do we use it, okay? A function was there from A to B. Another function was there from B to A. Let's say we have taken. Okay. Now, if I want to find FOG, means what basically we want to do is, let's see everybody here. Let's hide this one. Yeah. Shall everybody pay attention here? For those who are not writing answers or not trying, do try next time. Okay, I want answers from everybody. Right or wrong, we don't care. Sek, Danish and others also write answers. Okay. Chalo, function is there from where to where? A to B. And another function is from where to where? I've taken, let's say, from B to A. I've just taken the reverse. If I'm doing FOGX, what I mean by this is, in this function f, I'm putting the another function gx as a parameter. See, the function was earlier we used to write function of x, means here the domain values were what? X. Okay, now the domain values is what? This part. Gx, not x, g of x. Clear? So let's understand this with a simple example. Let's say my function is from R to R. R to R means real valued functions. Domain and range both are real numbers, okay? And fx is given as tan x. and my another function gx is there, which is also r to r, real valued function, and that is equal to x square. So if I ask a student what is f o gx, what will be the answer? Tell me what will be the answer. Let's see. Whoever knows, okay, otherwise I'll again explain, so don't worry. Tell me what will be the answer here. Come on, come on, come on, answers. What will be the answers? Any difficulties in sound hearing or something, students? Hi Lokesh. Tan x square, tan x square, tan x square, tan square 2x. Okay. So basically what we have done, in the function tan, wherever I was putting x, instead of that I'll be putting what? G of x. So what will be tan of, and g of x is what? X square. So tan x square. Hi Rohan. Correct. So I think so everybody got tan x square. Clear? Anybody has doubt in this how we got FOG? Now if you got FOG, come on students, tell me what will be the answer for GOF. Come on students, tell me the answer for GOF fast. Let's see. It's not visible here, I'll put here GOF. Tell me the answer fast. Come on, come on, come on fast. Tan x square, Rohan, okay. So here in GOF, what we do, take the function g. What is the function g? Tan. And in that function, instead of putting x, what will put? The whole fx. So in that, what is fx? What is fx, students? Oh, sorry. My gx function is what? X square, no. So instead of putting x square, what I'll put? Tan x and then whole square. Clear? Desktop का sound है. Desktop का sound है. One second, students. अभी सुनो. आप लोग सुनो अभी. Check it fast. So if I ask student, Chalo. Let's see, students. I'll explain again. A lot of students, they had difficulty in this part. One second. Yeah. Sure. Class postponed to 3:30. Whose class postponed, kid? See here. Just we were getting some sound. It was, what do you say? The geyser was on and the pipe got heated up. So smoke was coming on that. So that's why the sound was there a bit. I think so now the sound will be okay. Now let's see. So what we have is the function, we have taken the gx function as x square. So my g of x function is x square and f of x function is tan x. Now understand, when we are doing g o f x, it means what? In the function g, I am putting fx. So what is my function g? If I am putting x, I am getting x square. So g of fx will give me what? Fx whole square, correct? So what is my fx? Tan x whole square, clear? So that is also equal to tan square x. Anybody now doubt? Tell me. Anybody now doubt? Yes, no, yes, no. Come on, everybody. Where you all went? Fast, everybody. Anybody doubt with this? Rohan, Pavitra ma'am, any doubt, students? Is any disturbance sounds now coming? Because earlier it was the, geyser was on, so that's why. So now I think so it will be proper. No doubt. Come on, fast, no doubt, good. Clear? Clear, sir. Okay, good. Pavitra, clear, not clear? Rohan, clear, good. Pinaki, crystal clear. Damn good. Should be crystal clear. Yes, Kartike, good. Okay. Chalo, so we got about FOG and GOF. Let's talk about invertible functions. Okay. So two functions, their inverse is possible if, and function f is inverse of g if FOG is equal to GOF. Very simple condition. The function fx and gx, they are inverse of each other if this condition follows. If this condition is there. Clear? And the other way to check inverse is what? 1, 1 on 2. If a function is 1, 1 on 2, then also it's invertible. And if a function's FOG is equal to GOF, then also it is invertible. There are two ways to check if a function is invertible or not. Okay. The number one is FOG is equal to GOF. Number one. Number two is 1, 1 on 2. Both, either of one you can use it to check whether it is invertible or not. And such a function is known as bijective function. A function which is 1, 1 on 2 is known as bijective function. Write down this part, everybody, important. This part, everybody, important. Clear? This part, write down, everybody, important. Come on, write down fast. Once written, do tell me, okay? Chalo, done everybody, fast. Today class till 4 p.m. After that 5 we'll have chemistry students. Ma'am will be teaching about coordination compounds, okay? And then, don't worry, 7:30 sharp today will be starting 7:30 to 11:30. Maths and physics both. Maths PYQ will be left and physics electric potential and capacitance. Electric potential and capacitance will be finishing for CT and Comedk. So be there, okay? Don't go anywhere, be there. 7:30 to 11:30, it can be 12 also. Okay. Clear? Chalo. Everybody is able to understand. What is bijective function, which is 1 1 on 2? Two ways to show if the function is inverse or not. What is? Either if I'm able to show FOG equal to GF, that is one way, done my work, or if I'm able to show 1 1 on 2 function. Clear? Chalo. Chalo, everybody done. Next we'll talk about binary operations. Very simple. Clear? Now, no dinner, huh? You can have dinner while doing the class, huh? Correct, huh? You can have dinner while doing the class also. Okay. You won't get separate time for dinner and all, huh? Separately sitting in front of TV, switch it on, and then watching and then eating the dinner after 30 days. Huh? Clear? Chalo. Now, what is binary operation, students? Understand. So binary operation, first it is defined on some set of integers or natural numbers or whatever it is. Let's say if I'm defining binary operation on natural numbers and my operator is what? Plus. So what does binary operation says that it will be a binary operation if by doing this operation I'm getting the same thing. Means if I take two natural numbers and if I use the plus operator and by adding these two, if I generate a natural number only, then it is a binary operation. Now, is minus a binary operation? You'll say no, sir. Why? Sir, 4 minus 2, 4 is a natural number. Very good, sir. 2, natural number. Very good, sir. But 4 minus 2, when I do, I get 2. Yes, natural number. So what is the doubt in that? Sir, if I do the opposite, 2 minus 4, here also this is natural number. This is also a natural number. But 2 minus 4 is minus 2. Not a natural number, sir. Not a natural number. So minus is not a natural number. Correct? Clear? So minus operator is not a binary operation. Okay. Why? Because if I do minus, okay, the minus operator and the number which is here, if that is small than this number, then what will happen? We'll end up getting not a natural number. So that's why we can say it is not a binary operation. So can anybody tell me division? Is division a binary operator? Is division a binary operator for natural numbers? Let me put this question. Is division a binary operation on set of natural numbers? Tell me yes, no, come on fast. Take your time. What do you need to check here? What you need to check here is that if I do a division operation, okay, on the natural numbers, will I always get a natural number? If I do a division, let's say if I'm dividing 4 is to 2, 4 divided by 2, damn good, sir, natural number. But what if, sir, if I divide 2 divided by 4, I'll get half. Is half a natural number? No, sir. So can it be? No, not a binary operation. Clear, everybody? Yes, no, I want everyone's answer. Come on, yes, no, fast. ईमानदारी से बताना बच्चों सबको, honestly you have to say whether you got it, you didn't get. Okay, tell me your answer. Chalo. Everybody no means no doubt or nothing. Chalo. Clear. Chalo. Where is Gokul? Gokul clear. Vimal clear. Okay. Done. Chalo. Now what if I say is division, subtraction, binary operation on set of integers? BO means binary operation on set of integers. Now tell me yes or no. Option 1 yes, option 2 no. Put out your option yes or no fast on the chat screen. Put the options yes, no, on the chat screen. Google got it, okay? Everybody key do say, okay? Whether you got, didn't get, so we get that feeling. Teachers feeling that students are able to understand. That's a very good feeling, okay? That's one good feeling that keeps motivating a teacher, okay? So, come on. Yes, no in the chat screen. Yes, no. Pavitra, yes. Rohan, yes. Okay. Danish, yes. What about others? Unknown girl, yes. Vinnubai, yes. Karthike, one step. No for division, sir. No for division and yes for subtraction. Lucky, no. No for what, kid? Two options. Okay. So, for those people who said yes, understand. For division, if I do, is half an integer? Everybody tell me. Is half an integer? Yes, no. Is half an integer? Because when I'm dividing 2 divided by 4, I'm getting a fraction. This is a real number, a rational number, but not an integer. Correct? It's a real number, rational number, but not an integer. So division, not binary operation. Correct? What about subtraction? Yes, definitely. We can get negative of that. So subtraction is there. Clear everyone? Subtraction, yes, definitely. But division, no. Subtraction, yes. But division, no. Clear? Now everybody got it. Karthike, good. Chalo. Got it, everybody? It's too much of light. Clear. Chalo. Next is identity element. See, identity element is what? In multiplication, it is 1. If I multiply anything with 1, I'll get the same number. 2 into 1, 2. 3 into 1, 3. So same way here, in case of binary operation, if I take a element A, do a star operation and do E. So if I get A star E or E star A as A only, then that E is called the identity element. E is called the identity element. Clear, everybody? What is the identity element in normal sense? Like, see, in case of multiplication, if I take any number multiply with 1, I'll get what? That same number. So in case of binary operation, if I do a star operation on E, and that is same thing as E star A, and I'm able to get the same number A, then I say this is a identity. This is a identity element. Clear? And next, inverse. If I multiply, see, inverse also we know, if I take a number 2 and if I multiply with its reciprocal half, so what I should get? 1. So means A and B are inverse of each other. This is my A, this is my B. So they are inverse of each other. So A star B is what? If A star B is equal to E, then we say B is inverse of A or A is inverse of B. Correct? Vice versa. Clear, everybody? Check it. Check it, everybody, fast. Put it clear, not clear, doubt, no doubt. If no doubt, put ND in the chat section. This whole page, identity element and inverse, if you understood, put ND in the chat section. If not, I'll again explain, no issues. Fast. Karthikeya repeats, sir. Okay. See Karthikeya. And what happens is identity means what? Identity, remember in mind, is 1. If I take any number, multiply with 1. What I'll get? The same number. Same thing in case of binary operations. If I take any element, do a star operation in E, and I am able to get the same element, means no change in multiplying with this E, then I say that E is the identity element. Clear? Now, and if this is the identity element, so if I multiply two elements A as star with B, and if I'm able to get the identity, it means what? These two are inverse of each other. Let's take an example and understand. The example is, let's say if I took a number 3, if I did 3 star 1 and I'm getting, what is it, 3 only, it means 1 is identity. And if I take 3 star with 1 by 3, and if I'm able to get the identity element here, it means they are reciprocal of each other or inverse. Clear? Yes, no? Once inverse. Inverse, same thing da. See, if I've taken a number 2, multiplied with its reciprocal, if I'm able to get the identity, just like in matrix what we are doing, A, B, if I multiply these two matrices and I'm able to get an identity matrix, it means what? A and B are inverse of each other. Similarly, in binary operations, if I take A, do a star operation with B, and I'm able to get this identity element. Identity element acts as 1, or in case of matrices acts as the identity matrix. Okay. That means E is always. Now in case of binary operation, E doesn't always has to be 1. See, what do you say, Vinayak? Okay. If I do for multiplication, everybody come here, understand. If I take for multiplication telling addition, what will be my identity element? If I take addition plus 1, what will be identity element for this? 0. Any number if I take, if I add with 0, will it give me the same value? Yes or no? So depends on each operator. We can't fix it that this is 1. Clear? For multiplication, yes, you can say any number multiplied with 1 will give me that number only. But for addition, it will be 0. So here the identity element is what? This one. Here the identity element is this one. So we can't fix it that E value is always 1. In case of multiplication, yes, definitely it is 1. In case of addition, it is definitely what? 0. Clear, everybody? So identity element means whatever the operation you're performing, by doing that operation, you should get the same element. Means A, and whatever the operation I perform here, I'm multiplying with E, I should get the same. So if this thing happens, if this happens, then we say that this E is identity element. Clear? And if I have two numbers A and B, and if I do any operation, I don't know what operation I'm doing, and if I'm able to generate the identity element, then I can say these two are inverse of each other. These two are inverse of each other. Clear? Got it, everybody? Yes, no? If no, again I'll explain, no worries. Because this is a good concept, don't get confused too much. Just remember that part is, if something has to be identity, inverse will always be 1. No, Rohan. What is additive inverse? Do you remember? It can be any operator. Now, I'm just putting star as any operator. Now, if I talk about, students understand, what do you say? Additive inverse. Additive inverse. So in case of additive inverse, I need to get my identity element, correct? Means A addition with another number so that I can get the identity element. This is my identity element in case of addition. Clear? So additive inverse became what? See? Correct. It not always has to be 0 or something like that. Clear? Yeah, inverse depends on the operator used. See here, in case of additive, what do you say? In case of plus operator, in what do you say, this is different. In case of this, it is different. So the main target, what is it? Whenever we talk about inverse, it should be any element, what do you say, operator with other element should give me identity. Okay, in general sense, you keep it like this. You write it like this: any element, whatever the operation you perform here, this is the operation box, with another element, if it is giving me identity element, I don't know what is identity, don't classify. If it is giving me identity element, it means that these two are inverse of each other. Clear, everyone? Clear? Any element doing whatever operation you want with another element, if it is giving me the identity element for that operation, then they are inverse of each other. Clear? You can write down this one. Very simple. Very simple, very easy. Okay? Just this much you put it in brain. Any element you take, do any kind of operation with any other element. If you're able to get that operator's identity element, done. Chill. That is inverse. Clear, everyone? Clear, clear, clear. Others now clear. Good, Nishat. What about others? Don't worry. In case again night I'll explain for those who are not clear. Okay? No doubt, Keshav. No doubt, Keshav. Come on, come on, come on. Vinnu bhai, no doubt. Vimal, no doubt. Lucky. Come on, Lucky. Clear. Okay, good, good. Now this is one formula, just keep it in mind. It is the trick part, just keep it in mind. The number of binary operations of set A having n elements is n power n square. N power n square. That's it. Just keep it in mind. Nothing more than that you will need to use it. Just n power n square. That's it. Clear? This formula as a trick part, we don't need to go in depth of this. Just keep it as a as a trick. Now, clear, everyone? So this part done. Clear? We're done with whatever kind of questions that can be asked from sets, relations and functions. Now few domain range questions, let's just see. Okay, few things that you need to keep in mind about the other functions, okay, which we basically teach in mathematical tools and all. Now what about anything inside square root? Keep that in mind. Anything inside square root has to be what? Always positive, greater than 0. It can be equal also, greater than equal to 0. Clear? Keep this thing in mind. So if I give you a question, very important, fx is equal to root under of 2x plus 3. I tell you find the domain. What will be the domain, students, here? Means what are the values which are allowed for x? Domain means what? X values which are allowed to me without hampering the function. So I know anything which is inside the square root has to be positive. Okay, so what I can write? Anything, everybody say it with me, anything inside the square root always has to be positive. So 2x plus 3 has to be greater than or equal to 0. So 2x will be greater than or equal to what? I'll send this 3 that side, so it will be minus 3. So x, I'll divide whole thing by 2. X will be greater than or equal to what? Minus 3 by 2. So answer will be what? Minus 3 by 2, comma 0. Clear? Sorry, comma infinity. Check it. Yes, no in the comment section, everybody come on. Check it. Yes, no in the comment section, everybody come on fast. One important part, just teaching for the range domain part. Anything inside the square root has to be positive, greater than or equal to 0. Anything inside the square root has to be greater than or equal to 0. Correct. So whatever they put it inside the square, whether it is tan, log, cot, whatever it is, anything inside square root has to be greater than or equal to 0. Clear? Everybody, yes, no in the chat section fast. Come on, students. Fast रे बाबा, जल्दी करो. Come on, fast. Chalo. Now same question, I just gave it like this. Fx is equal to 1 by root under of 2x plus 3. What will be the answer? You tell me. What will be the answer, students? Come on, you all have to tell me fast. Correct रे बाबा, अभी उसी के बारे में डिस्कस करेगा हम लोग. केशव will discuss about that only. When it is open, when it is closed. Close means it is taking this value. Whenever equal to means we'll be taking this value. 3 by 2 is included. See, I did this chapter, so I explained whenever we are taking 3 by 2 and we are going till here, means I am taking this value 3 by 2 and moving on ahead. So that time I'll use a close bracket. If I'm not taking 3 by 2 and just moving on ahead, so it will open bracket. Clear? What will be the answer of this? Come on fast, come on fast. A question for life. Come on fast. Come on fast, you do it. Come on fast. Minus, we got minus 3 by 2 is not included. Okay. What about others? Answers. Done everybody? So Keshav got, Nishat got, Lucky got. See, whenever it is in the denominator, anything inside in the denominator part can never be 0. So my denominator, whatever the function, can never be equal to 0. Always keep that in mind, everybody. The denominator can never be equal to 0. Denominator can never be equal to 0. So now this can only be 2x plus 3 is greater than 0. So 2x is greater than minus 3. So x is greater than minus 3 by 2. So see, only greater than sign is there, no equal to. So here it will be what? Minus 3 by 2 to infinity. Minus 3 by 2 to infinity. Clear everybody? Minus 3 by 2 to infinity. Why Nishat? Why 3 by 2 to 0? See, this whatever inside the square root has to be what? Positive. So just greater than 0, no? So if I put a value minus 3 by 2 and bigger than that, it won't be anywhere negative. So why till 0? Clear? Got it, Nishat? What about others? Come on. What about others? Got it, didn't get? Come on, fast. Everybody got it? Yes, no. Got it, everybody? Clear, clear. Anybody has doubt? Gokul, Lucky, Amol, Rohan. Very important part, okay? Come on, fast, fast, students. Any doubt, any doubt, any doubt? Nobody has any doubt? Good, good, good. Chalo. So we got to know about square root. So anything inside the square root has always, it always has to be positive. And that square root, if it is in the denominator, what will happen? Okay, I'll explain, Rohan. If the square root is in the denominator, it can never be equal to 0. So anything which is in the denominator can never be equal to 0 because denominator 1 by 0 not defined. Now again understand, I'll explain. In the square root we had, 2x plus 3. So what I did, whatever is inside the square root has to be greater than equal to 0 if it is in the numerator part. Okay. So 2x, what I'll do, add both sides minus 3, minus 3. So 2x is greater than equal to minus 3. Divide whole thing by 2. So x is greater than equal to minus 3 by 2. So if you draw a number line, this is minus 3 by 2, this is 0, these are all positive numbers. So it is taking minus 3 by 2 and it is greater than that. So this side. So from minus 3 by 2 it is going till what part? Till infinite in the positive side. Clear? Clear, Rohan? Infinity part? Clear? Chalo, everybody got it till here? Everybody got it till here? Any doubt? Any doubt? Slowly, slowly, this all part, okay, we'll be getting it done, so don't worry. Clear, huh? Chalo, chalo, chalo. No doubt, everybody. Rohan got it done? Okay, clear, good. So, today class till here. 5 p.m. everybody, chemistry class. In the app, mostly it will be done or in Google Meet. Okay. 5, ma'am, 5 bhej, no? Okay, mostly 5. And today ma'am will be discussing on the chapter coordination. So read about it so that you can ask more and more doubts. Coordination compounds, okay? Clear, everyone? Coordination compounds, okay? Now, bye everyone, and 7:30 my class, 7:30 my class, okay? For the chapter PYQ of RNF and then potential and capacitance, Clear? Don't skip it. So number of binary operations of set of elements in next class. Yeah. Number of binary operations is just one formula which is asked, not much detail is asked in CT and Comedk. So just that much a formula. That's it. Clear? Chalo. Now for those not enrolled in the course, do enroll fast. Okay, done? Done, everybody? Keep it till here for today. Chalo.